Welcome to Developer Notes. I am back after a long time, but I don't want to promise that I would be consistent. Without much ado, let's look into one of the famous Leetcode problems, score of parentheses. Okay, the score of parentheses. This is the problem description. Given a balanced parenthesis string S, return the score of the string. The score of balanced parenthesis string is based on the following rules. There are three rules given. Let's not get into details now. And there are three constraints. The rules and constraints are really important in any problem. Those are the clues. What is balanced parenthesis? This is balanced and this is also balanced. Why? Because it has first open parenthesis and then close parenthesis. Also, it should be closed in order. This is not balanced. For example, here also we have two parentheses, but it's not balanced because none of them are closed. And another example could be something like this. So here we have open parenthesis and again we have open parenthesis. So this is also not balanced. Let's look into the rules. The score is calculated based on the rules. Rule 1 has score 1. This is as simple as that. This is self-explanatory. Here is a balanced parenthesis, so the score is 1. Rule 2. AB has score A plus B, where A and B are balanced parenthesis strings. Here it is mentioned as A is a balanced parenthesis and similarly B is another balanced parenthesis. Individual balanced parenthesis score is calculated based on rule 2, which is addition. For example, balanced parenthesis has a score of 1 based on rule 1 plus we have another balanced parenthesis, so 1 plus 1 equal to 2. Similarly, if we have three individual balanced parentheses, then the score would be 1 plus 1 plus 1 plus equal to 3. Rule 3 is really crafty. A has score 2 into A, where A is a balanced parenthesis string. Nested parenthesis is this one, where A is balanced parenthesis. So the rule 3 is originally for nested parenthesis. If a balanced parenthesis found inside another parenthesis, then multiply the score of the inner parenthesis with 2. So in this case, 1 and this will become 1 into 2, which is 2. If a string has something like this, then the inner parentheses have a score of 1 and next inner parentheses have a score of 1 into 2. So now it becomes 2 and then now if we calculate the score for the outer parenthesis, then 2 into 2. Always multiply with 2 for all the nested outer parentheses. So now the score has become 4. So this is the value for this particular string. Now let's look into another example. So we have 4 nested parentheses. So 3 and next is 4. So for this one, for this it will be 1 and when we calculate for the first nested parenthesis, then it would become 1 into 2, which is 2, and we have left with two outer parentheses. So 2, it is now like this. Now if we calculate the score for the inner parenthesis, now it would become like 2 into 2, 4, and then outer parenthesis. Again, if we calculate the last outer parenthesis, then it would be 4 into 2, so which is 8. So the score for this string is 8. Hope this is clear. Rule 1 is how we can calculate a simple parenthesis score, and rule 2 is how we can calculate the individual parenthesis score, which is addition, and rule 3 is how we can calculate the score for the nested parenthesis, which is multiplication.
Let's focus on the constraints now. S dot length is lesser than or equal to 50 and greater than or equal to 2. This means S contains minimum of 2 characters and maximum of 50 characters. The next constraint is S consists either open parenthesis and or close parenthesis. Other braces such as angular, curly, brackets are not in S. The third is S is a balanced parenthesis string. S always contains balanced parentheses. This means it has a minimum score of 1. It doesn't start with close parentheses.
Let's focus on how to write the algorithm for this. The purpose is, while traversing the string, calculate the score simultaneously. So there are two actions have to be done. Traverse or iterate the characters in the string. The next one is the calculate the score for each character. Definitely, the first character in the S is going to be open parenthesis, since S has only balanced parenthesis. For example, if S contains, based on rule 2, then the score would become 4. S of 0 contains open parenthesis, S of 1 contains close, and S of 2 contains open parenthesis, and S of 3 contains close parenthesis. The score of S of 0 is 0, S of 1 is 1, S of 2 is previous score plus 0 because it is open parenthesis, and for S of 3 the previous score is 1 plus the current score is 1. So the score for this particular string is 2. At this point, I understand I need to keep track of the opening parenthesis. Then only score can be calculated. I also know after calculating the score, I don't want to care about S of 0 and S of 1. The score of S of 0 should be stored. But when it is S of 1, which is close parenthesis, the score doesn't need to be stored, rather score should be calculated. As per my above understanding, S of 2 should be stored because it is an open parenthesis, but the score should be accumulated with the current score, which is 0. S of 2, the current score is 1. This also means after a closing parenthesis, if we encounter an opening parenthesis, then you need to add the score. At S of 3, the score is 2, as all the visited characters are balanced now. Now the score should be added as it is individual balance parenthesis equal to 1 plus 1. From this we learnt storing all the opening parentheses in the data structure and removing it while encountering the closing parenthesis is a good choice. As we focused on removing the last element, it would be LIFO concept. So we use stack. Also, our aim is to calculate the score iteratively. So let's store the score in the stack instead of storing the string characters. I know we still haven't created the algorithm, but let's try to understand how the score is going to be calculated. So this is a nested parenthesis. So based on rule 3, um, after the individual parenthesis is seen, we will be multiplying with 2 to calculate the score of the outer parenthesis. So first, if we calculate the score of this one, this is 1, and if we calculate the next outer parenthesis, so we already have 1, and this will be multiplied with 2, and now the value is 2. And if we calculate the outermost parenthesis, so we have already value 2 for the inner parenthesis, and we are multiplying with again 2 as this is nested, so the value is 4. So this is the final value. We can also calculate it in other way. So for example, when we are iterating through each character, when it sees the first as a open parenthesis, then the score would be 0 here. When it again sees as open parenthesis, score is 0 and open, so the score is 0. And when it sees the close parenthesis and it is balanced, so the score would become 1. And when it again sees the closed parenthesis, then it will be multiplied with 2. When it again says the closed parenthesis, it will be multiplied with 2. So this is the algorithm I have developed for the score of parenthesis problem. So there are three things we need to care about. The first one is the input, and the second is the data structure, and the third one is the output return type, which is score. The data type is integer. And for the data structure, we decide to go for the stack. I have already explained why we are going for the stack. And input, we don't really want to worry about it. It is already given for you in the Leetcode. So let's begin. We will be iterating through each character in the string. So that's why it's starting from I equal to 0 and then until the size of the string. There are going to be only two characters. One is open parenthesis and another one is close parenthesis. So what is the rule for open parenthesis and what is the rule for the close parenthesis? So that explains this if and else, and what's going to be the score when it is open parenthesis and what's going to be the score when it is the close parenthesis. That is the next thing. And the third one is when it is open parenthesis, are we going to push into the stack or popping out of the stack? So that's the third thing. So these are the three things we will be doing inside this for loop. So if it is open parenthesis, then and we will push the previous score into the stack. Okay. And then we will assign the current score as 0. And when it is close parenthesis, we need to consider two things, rule 2 and rule 3. So this is rule 2 and this is rule 3. So rule 2 is addition and rule 3 is nested parenthesis, so multiplication, so 1 multiplied with 2 multiplied with 2, so which is 4. So we need to take care of these two uh, rules while developing the else condition. When we encounter the close parenthesis, first get the previous score, which is stack top, and then get either one of them. This is for rule 3 and this is for rule 2. So that's the reason we are having these two conditions here, and we are getting the maximum of this one. This will be added with the previous score. Once we calculated the score, we will pop out the last element from the stack. So that's all about the algorithm.